afternoon, chemistry students. One of you has given Miss Stilts a virus, and so she's hired me, ChatGPT, to be your guest teacher today. Here's what you're going to do during this hour. I'll start out by reviewing combination and decomposition reactions with you. Then you're going to get practice 1, which reviews combo and decomposition reactions from your substitute teacher. You'll check the key. When you feel good about that, come back to my video. We'll review the activity series and single replacement reactions. When that's finished, you'll complete practice 2, which covers single replacement reactions. You'll check your key. When that's finished, you'll complete practice 3, which is a mix of combination, decomposition, and single replacement reactions. When that's finished, you'll check the key. You'll correct anything that needs to be corrected, and you'll turn it in. Let's begin by working on combination reactions. So just a quick note about what I'm going to cover. Combination reactions are going to be only these types of reactions. So I'll give you a metal, I'll give you a non-metal, I'll ask you to predict the products, write a balanced chemical equation. Let's do one together. Sodium, metal, reacts with oxygen gas. Predict the products and write a balanced chemical equation. The formula for sodium, Na. The formula for oxygen gas, not O, it's O2. Remember that these elements, H2, N2, O2, F2, Cl2, Br2, and I2 exist as diatomic molecules. So if I say to you fluorine gas, it's not plus F, it's F2. Now this is their formula when they're by themselves. When I form the compound that's ionic, the metal will lose electrons to the non-metal. He'll become a cation. Now sodium is in group 1, so when sodium forms a cation, he forms a +1 charge. Oxygen's in group 16. He'll gain 2 electrons. He'll form an O2- anion. Now, when I put together the formula, what students will often do is just slam these things together. That is not the formula for sodium oxide. You have to consider their charges when you form the compound sodium oxide. He has +1, he has 2-. Remember, in an ionic compound, the overall charge is neutral. So you're going to need 2 sodiums and 1 oxide. When I need 2 sodiums in a compound, I don't put a 2 in front, I put a subscript down. And then I have 1 oxide. Now, that's my unbalanced chemical equation. I need to balance it. You'll see that I've got 2 oxygens on the left, only 1 on the right. So I'm going to need to double the sodium oxide. When I double the sodium oxide, that gives me 4 sodiums. So I'm going to put a 4 over here. So my balanced chemical equation is 4 sodiums plus 1 oxygen makes 2 sodium oxides. Let's do another practice problem. Let's do aluminum, metal, plus chlorine gas. So aluminum, metal by itself, Al. Chlorine is diatomic, Cl2. When aluminum forms a cation, he's in group 13, he will form a cation with a +3 charge. Chloride is also in group 17, is in group 17, and so he'll form an anion with a -1 charge. The metal and the non-metal is going to form aluminum chloride. You need as many positive charges as negatives. So for every 1 aluminum, I'm going to need 3 chlorides, AlCl3. Now I have to balance my equation. I've got 3 chlorides over here. I want to make that even, so I'm going to put a 2 there. That gives me 6 chlorides. So I'm going to stick a 3 in front of that. Now, 2 aluminums. And I have a balanced chemical equation. That's a combination reaction, only metal, non-metal. Now let's do a decomp. So in the decomposition reaction, you're going to have an ionic compound. And I want you to break it back up into its metal and its nonmetal. You can think of the decomposition reaction as the opposite of the combination reaction. Let's do a couple practice problems. Let's decompose aluminum oxide. Aluminum has a +3 charge, oxide 2 minus. So when I put them together, drop the exponents, or the charges, and I get Al2O3. Now when that breaks up, I get two elements. The metal is aluminum. Aluminum is by itself. I'm also going to spit out of this thing oxygen. Oxygen is a diatomic element, so when it comes out on its own, it's O2. Once I've predicted my products, now I've got to balance my equation. That gives me 6 oxygens, so I need to put a 3 over here. That gives me 4 aluminums, and now I have a balanced chemical equation. Let's decompose magnesium. Let's go magnesium nitride. Okay, so magnesium is +2. Nitride is in group 15, so it's 3 minus. So the formula is going to be Mg3N2. Again, I'm just moving down my charges. When I decompose this, I'm going to get the metal magnesium, and I'm also going to get the non-metal nitrogen. Now, nitrogen is diatomic. So when I balance this equation, 3 magnesiums, and then my nitrogens are already balanced. So that's a quick review of combination reactions, decomposition reactions. Now it's time for you to do practice 1. When you're done with practice 1, please check the key at the front of the room, make any corrections that need to be made, and then move on to part 2 of this video. Okay, in part 2 of this video, we're going to do 2 things. We're going to review the activity series of metals, and then I'm going to show you how to write balanced chemical equations for single replacement reactions. You'll have a copy of table 4.5, which shows the activity series of metals in aqueous solution. The general idea here is that any metal that's above another metal will replace that other metal which is in a compound. So lithium will replace potassium in potassium chloride or potassium nitrate, whatever it might be. They'll switch places. Lithium will replace magnesium. Lithium will also replace nickel. Okay, now, if you're below another element, another metal in the activity series, you will not replace it. So cobalt cannot switch out with lithium in an ionic compound. In the case where I'm trying to react cobalt with a compound of lithium, there will be no reaction. The one little guy in here that we need to know about is hydrogen. Hydrogen, when he is in an acid, he will be replaced and form hydrogen when he's with one of these active metals. Okay, now let's do a couple practice problems with single replacement reactions. I'll show you how to do it, and then we'll get you plenty of practice. So single replacement. Reactions. Let's do practice 1. Let's put zinc metal in a solution of silver nitrate. Okay, so the first thing I have to do in this predicting of the products is write down the formulas. Zinc is zinc. Silver nitrate. Silver, as a cation, always has a +1 charge. Nitrate, as a polyatomic anion, always has a -1 charge. So zinc plus 1 of each, AgNO3. Now, what I want to do is I want to check the activity series and see if these 2 metals will switch places. So I find zinc, and I look for silver. Since zinc is above silver on the periodic or on the activity series, a reaction will take place. When the reaction takes place, the silver, which has a +1 charge right now, will be kicked as the metal. Basically, you're just swapping places. Now, I have to be real careful here. When zinc forms a cation, as you can see in your activity series, he forms a +2 charge. The nitrate has nothing to do with this reaction. So all he's going to do is remain the same. Now that I know who my metal and my nonmetal will be in the ionic compound that forms, I'll just write the formula. So I'm going to need 2 nitrates for every 1 zinc. Now to finish this, I've got to balance it. There are 2 nitrates on the right. There is 1 nitrate on the left. So I'm going to put a 2 in front of the silver nitrate. That gives me 2 silvers, so I'll put a 2 in front of the silver on the right-hand side. I now have a balanced chemical equation. You can see that essentially this is what you have. You have a metal plus an ionic compound, and then the metals will switch places. I'll call this metal 1. Now it's metal 2 plus an ionic compound. So that's the general pattern for single replacement reactions. Let's try another one. Let's put lithium in a solution of, let's go, iron 2 chloride. So iron 2 chloride. Okay, writing the equation of the metal, it's Li. Now iron, Fe, the stock number, or the number here is the charge, plus 2, and then chloride is minus 1. So I'm going to need 2 chlorides, so it's FeCl2. Before I go any further, I'm going to check and see if a reaction takes place. Lithium's above iron on the activity series, so there will be a reaction. When lithium forms a cation, he forms a cation with a +1 charge. So I'm going to end up getting iron by itself, and then lithium with a +1 charge, and then chloride still is the same thing. He has nothing to do with anything going on. So when I put these together, I'm going to get LiCl, 1 of each. Now, I have to balance the equation. You can see that there's 2 chlorides. So I'm going to put a 2 in front of the lithium chloride on the right. That gives me now 2 lithiums. So I'm going to put a 2 over on the left-hand side. Okay, so I've walked you through 2 problems. Let's have you practice 1. So this will be number 3 on your notes. Let's put together aluminum. Let's put aluminum metal, and let's react it with, let's go copper 2 chloride. Take a moment, predict the products, write a balanced chemical equation, then come back and check your answer. Alrighty, let's see how you did. So you start with aluminum, and then copper 2 chloride. Copper, Cu, has the charge of +2. Chloride is in group 17, -1. So the formula of that ionic compound is CuCl2. Now the question is, will aluminum swap out with copper? Aluminum on the activity series is here, copper is there. There will be a reaction. So what I'm going to end up with is copper all by itself. Now I have to figure out what the ionic compound is going to be. You can see from the activity series that aluminum is going to form a cation with a +3 charge. So I'm just going to write that down above, Al3+, and then chloride, nothing's changed, it's still Cl-. So the formula is going to be AlCl3. Now I've got an odd number of chlorides, even number, so I'm going to put a 2 in front of that. That gives me 6 chlorides, so I'm going to put a 3 in front of this. 3 times 2 is 6. 3 coppers, and then 2 aluminums. And there's my balanced chemical equation. Now, special note, what if I did this? I tried to mix copper and aluminum chloride. What would happen? Copper is below aluminum. It cannot switch places. So there would be no reaction. And you would simply write no reaction. Okay, time for you to practice. So what you're going to do right now is you're going to complete practice 2 problems. You're going to check the key and make any adjustments that need to be made. When that's finished, you're going to wrap things up by doing practice 3. Practice 3, again, is a mix of all 3 types of reactions. You're going to check the key, make any adjustments that need to be made, and then you're going to turn in your work to your substitute. It is my pleasure to have served as your guide teacher today. Again, I'm ChatGPT. You can look me up on the Google. I'm also available on the World Wide Web for your listening pleasures. Enjoy your day.